Okay, so let's look at chemistry. So we're going to look at questions relating to moles, mass, and chemical bonding that were asked in 2016 and 2017. So in this question, we have the first one. What is meant by limiting reactant? What is a limiting reactant? Okay, so a limiting reactant is a reactant that limits the amount of product made during a chemical reaction. So I'm going to say it is a reactant. It is a reactant that limits the amount of product made during a chemical reaction. During a chemical reaction. Or for you to understand it better, so a limiting reactant is a reactant that is small in quantity. Yeah, so it's a reactant that is in small quantity, in other words. But this is a formal definition. So a reactant that limits the amount of product made during a chemical reaction, that will be a limiting reactant. So B says 2.4 grams of magnesium reacts with 0.30 moles of hydrochloric acid. So our first question is write the balanced chemical equation. Write the balanced chemical equation. So here your job is to first of all know the symbols of the elements and the compounds used. So if you know the symbols, and if you also know, you have an idea of what happens if you have two different elements, then you'll be able to predict the products formed. Okay, so magnesium reacts with hydrochloric acid. So the symbol for magnesium, it's capital letter M and small letter G. So we are going to write magnesium. You also indicate its state. So magnesium is a solid. So I indicate like that, plus hydrochloric acid. So hydrochloric acid is HCl. So its state is aqueous. So this will give us magnesium chloride, which is an aqueous. It's an aqueous plus hydrogen gas. So when balancing a chemical equation, so that's your first part. Write the balanced chemical equation. So we've written the equation, and then our next step is to balance it. So to balance a chemical equation, you first of all start with other elements other than hydrogen and oxygen. So here we are going to ignore hydrogen. We are first of all going to see magnesium and chlorine. So magnesium here is 1 and magnesium here is 2. Chlorine here is 2. So let's go ahead and balance our left side. Okay, so by putting a 2 here, so by putting that 2, you have 2 hydrogen and here 2 hydrogen. So automatically our hydrogen has balanced. So that is done. So your next question says determine the limiting reactant. So in our question we have 2.4 grams of magnesium reacts with 0.3 moles of hydrochloric acid. So we have the moles of this and we have the mass of this. Okay, so our job is to find that reactant that will produce the least number of moles of a product. So that reactant that will produce the least number of moles of a product, that will be our limiting reactant. So let's start. Okay. Solution. So I'm going to calculate for magnesium. Okay. So I'm going to find the number of moles of magnesium. The number of moles of magnesium. So we know that number of moles is equal to mass over molar mass. Okay. So this will be equal to, the mass is 2.4. This one, which is given in the question, that is your mass. Okay, mass is in grams. And the molar mass, you check on the periodic table. You go to where magnesium is and find the molar mass. Okay, so you're going to find that it is 24.3 if you check on the periodic table. Okay, so when you punch in a calculator, you find that your number of moles of magnesium will be 0.1. So we found the number of moles of magnesium. So we don't need to find the number of moles of hydrochloric acid because this was given. If we didn't have, we are going to find it. But now, since we've already been given number of moles of hydrochloric acid, we just need to find the number of moles of magnesium, which is 0.1. Your next step is to now do mole to mole ratio. Okay, so we're going to say, here I'm going to write magnesium. This is magnesium. I'm going to compare it with a product, any product of your choice, but I'm going to choose hydrogen. Okay, I'm going to choose hydrogen. So from our equation, the whole numbers, or the coefficients, they represent number of moles. Okay, our balanced chemical equation represents, the coefficients represents the number of moles. So in here we have a coefficient here, 1 is silent, so we have 1 mole of magnesium. Magnesium we have 1, so we have 1 mole of magnesium producing 1 mole of hydrogen. So I'm going to say, if 1 mole of magnesium will give me 1 mole of hydrogen, what about 0.1 moles of magnesium, the one you found? Okay, what about 0.1 mole will give me X? So here you cross multiply this and that and this and that. So you're going to find that X is equal to 0.1 moles of hydrogen. So what we're saying is 0.1 mole of magnesium will produce 0.1 mole of hydrogen. Okay, so our job here is to compare magnesium and hydrochloric acid. So now that we have compared for magnesium, let's go ahead and compare for hydrochloric acid. Okay, so I'm going to compare hydrochloric acid and hydrogen. So on comparison, you can choose any product of your choice. So since here at first I chose hydrogen, even on the second one I need to choose the same hydrogen because we're comparing. Okay, I need to choose the same number of, the same product. Okay, so hydrogen, we have the number of moles, which is 0.30. So I'm going to write, so first of all I need to look at our balanced equation. So here we have 2 moles of hydrochloric acid. So I'm going to say, if 2 moles of hydrochloric acid gives me 1 mole of hydrogen, how about this number of moles? How about 0.30 moles will give me X? So we do the same, we cross multiply this and that, this and that. So X multiplied by 2 you're going to have 2x will be equal to 1 times that, it will be 0.3. So you divide by 2, so you have your x is equal to, so if you use your calculator, you should find 0.15 moles of hydrogen. So when you do this, now you compare. Hydrochloric acid produced 0.15 and magnesium produced 0.1. So which one is bigger between this one and this one? So you notice that 0.1 is smaller. So therefore, magnesium would be your limiting reactant. So therefore, magnesium is the limiting reactant. Magnesium is the limiting reactant. Okay, let's look at our next question. So here we have bodium. Its symbol is capital letter B and small letter O. Is a newly discovered element. It is a solid at room temperature and pressure. It can be cut with a knife. Reacts vigorously with water, liberating a flammable gas and forming a solution with a high pH. So these are the characteristics of this element. So here you notice that it is a solid. Okay, so if you look at your periodic table, okay, it is a solid. It reacts vigorously with water. So you need to now start thinking which elements on the periodic table reacts vigorously with water. Okay, and they are saying it forming a solution with high pH. So a solution with high pH means it is basic in nature. Okay, so a base, you know that a base carries OH. Something that has OH in it, we know that's a base. Okay, so to which group of the periodic table does bodium belong? So with these characteristics, you realize that these are characteristics of an element in group 1. An element in group 1. So the answer here is group 1. Okay, so your next question says, write a balanced chemical equation. Write a balanced chemical equation for the reaction between bodium and water. So a symbol we have for bodium is capital letter B, small letter O. So I'm going to say bodium solid, they have told me it's a solid, plus H2O liquid. Okay, so this will give me, since we are saying it has to do with something like OH, so I'm going to have bodium hydroxide, bodium small letter O and the small letter OH hydroxide will be an aqueous plus hydrogen gas, So I have bodium plus water giving me bodium hydroxide plus hydrogen gas. So now let's go ahead and balance it. So here, any element in group 1, these will be the products. So if we had lithium, it is going to be lithium hydroxide plus hydrogen. If it was which other element do we have? Potassium hydroxide plus hydrogen gas. So any element in group 1, an alkali metal that is, it will give you these products: lithium hydroxide plus hydrogen, bodium hydroxide plus hydrogen. So let's go ahead and balance it. So let's start with bodium. So bodium we have 1, here we have 1, okay, let's go to oxygen. Oxygen, here I have 1 and here I have 1. Okay, correct. So let's go to hydrogen. On my left I have 2, on my right I have 3, so it's not balanced. Okay, it's not balanced. So I'm going to put 2 here, I'm going to put a 2 here so that I have 4, and I'm going to put a 2 there so that I have 4 hydrogen. Okay, so I'm going to put a 2 there so that I balance the hydrogen. 2 there, so hydrogen is balanced. But here you notice that I now have 2 bodium, so oxygen has become 2, which has balanced with this one. So oxygen 2 balanced, but what has not been balanced now, it will be bodium. So what I do to balance bodium, I'm going to put a 2 on my left side, because here I only had 1. So when you do that, you'll have balanced the chemical equation. So that is how your chemical equation, a balanced chemical equation, would look like. Now let's look at our last question. State whether you would expect bodium carbonate to decompose on heating. Give a reason for your answer. So would we expect the carbonate of bodium to decompose upon heating? So the answer is no. Okay, so the answer is no. What is the reason? So the reason is, in group 1, it is only the carbonate of lithium that decomposes. The rest, they don't decompose. Okay, because it's only the carbonate of lithium, or it's only lithium carbonate, it's only lithium carbonate that decomposes. So that will be your answer. Okay. Okay, so this is how you answer questions regarding to chemical reactions, balancing, and coming up with your own chemical equation. So this is how it is done.